faster than the speed of light. This was a line from my favorite cartoons as a child, and who knows how many times you too have found yourself looking up at the sky on a starry night and wishing you could travel among the stars. Will we ever travel at the speed of light and beyond? Better still, could we travel among the stars as easily as we do a bus trip today? If you want to know the answer to this question, watch this video to the end. Click the subscribe button to keep up to date with upcoming content. Also share the video and don't forget to leave a like by clicking the thumbs up. Done? Let's go! We said, can you travel at the speed of light? Before we find out, let's go step by step. We won't need much. This is because light, despite being the fastest thing moving in space, is not that fast. As we said in a previous video, which I invite you to watch on the channel, light only moves at 300,000 kilometers per second, and if this allowed us to go 7.5 times around the Earth in 1 second, it would take us 4 years to reach the nearest star after the Sun, Proxima. But what technology do we currently have at our disposal to move through space? Space probes. The space probes launched in 1977, the Voyager probes, have traveled for over 46 years and now stand at the edge of our solar system. Voyager's speed is about 60,000 kilometers per hour, about 17 kilometers per second. Although this is a remarkable speed compared to terrestrial means of transport, it is still 18,000 times slower than the speed of light. If Voyager were to travel to Proxima Centauri, the nearest star, it would take over 75,000 years to reach it. Even if we used the Juno probe, currently the fastest object built by mankind, with a speed of about 265,000 kilometers per hour, it would still take over 16,000 years to reach Proxima Centauri. Photonic Sails. The Starship project, or more simply the Photonic Sails, is based on the use of sails that collect light and are propelled by light itself. But we are not talking about sunlight, which would be too weak to achieve the desired acceleration. How then? This is where another idea comes in. Using a very powerful and concentrated artificial light source, such as that produced by lasers. The idea is then to use a laser-powered photonic sail to travel to other stars. The sail would be opened in space around the Earth, and there it would be reached by a pulse of lasers that, according to calculations, could propel it within minutes at a speed of about 1/5 of the speed of light. Thus, the probe could reach the Proxima Centauri system in about 20 years, a huge time saver. Wormholes. What is a wormhole? Let's try to explain it simply. Instead of taking the usual route, you take a shorter one. In what sense? How can one go from one part of the universe to another simply by taking the shortest path? Imagine the fabric of the universe as a sheet of paper and us as an ant that has to cross it. What is the shortest path to get from one side of the sheet of paper to the other? Here, our ant that is at point A is eager to get to point B as quickly as possible. The shortest path would seem to be this, but it is not. Rather, it is to fold the paper in such a way that point A coincides or joins point B. In this way, In space, the same thing would happen. We could travel through wormhole-like shortcuts. You could enter a wormhole and find yourself almost instantaneously at a very distant point in space, and theoretically, for an outside observer, your journey would have taken place at a speed much faster than the speed of light. Only one problem: we have never found one. But by the physical laws of our universe, it is possible that they exist and have been generated naturally, and could one day even be generated artificially. How is this possible? This is because, as we said in a previous video, which I invite you to watch on the channel, objects with mass, for example our Sun, curve space and deform it. Some of them deform it in such a way as to tear or puncture the very fabric of the universe, such as black holes, which are not physically traversable anyway, whereas wormholes, theoretically, are. Let us explain again. Space is not rigid as Newton thought, otherwise bodies would move through it like balls rolling on a billiard table. But then how do you explain the fact that two bodies with mass attract each other? For example, our Sun is drawn to the center of our galaxy. The Earth is attracted to the Sun along with other planets precisely because of the deformation of the fabric of space. In this way, in turn, the Moon is drawn by the curvature that the Earth produces in space, and so on. Einstein gives us a better interpretation. For Einstein, a mass curves the surrounding space as if it were resting on an elastic cloth. When another smaller mass approaches, it will roll along the curvature of space towards the larger mass. It will appear that there is an attractive force between the two masses, but in reality there is not. It is simply the fact that the masses move in a curved space. This analogy of the elastic cloth is often used to understand the curvature of space and how gravity works. And so, yes, in the distant future we will perhaps be able to pass through wormholes to move through space. But let us now talk about the highlight of this video: the warp engine. Since 2011, scientist Harold White has been collaborating with NASA on the construction of the first warp engine, also like the wormholes, with the ability to curve or bend space and arrive anywhere in our galaxy in a matter of hours or days. The spaceship he plans is called Enterprise, like the Star Trek spaceship, and like it is powered by a warp engine capable of propelling it at speeds tens, hundreds or thousands of times the speed of light. These are the first futuristic images of the space vessel theorized by Harold White. They closely resemble the one presented in the film, with a large circular command bridge and two cylindrical thrusters on the sides. A spaceship equipped with a warp engine could then bend or compress space in front of it, and space would expand at the back. It would be space-time itself that would contract in front of the spacecraft, shortening distances, a bit like when, standing still or almost standing still, you roll up a carpet. Basically, we would be traveling at a speed much slower than light, but it would be space in front of us that would be coming towards us at speeds much faster than light, and thus without violating Einstein's theories. In a couple of weeks' journey, we could thus reach Alpha Centauri, 4.3 light-years away from Earth, and within seconds we could admire Mars and its canyon, the largest in the solar system. The giant Jupiter, only its red spot is 3 times the size of our Earth. Saturn and the detail of its rings, or in seconds we could be facing our majestic Sunday. The exciting thing is that Dr. White in 2021 has managed to produce the first energy bubble that can power, for now, a tiny warp engine. But this is only the beginning. The motto for this scientist is, If you can imagine it, you can do it. We can only marvel at what we have achieved, from the Voyager probes, which have challenged the boundaries of our solar system, to the solar sails, which use light itself to propel them towards the stars, to the mysterious wormholes, which could connect distant worlds, and finally the warp drive, which makes us dream of traveling between galaxies like in science fiction stories. As we look to the future, let us remember that we are part of a species that has reached the stars, and who knows what hidden wonders we have yet to discover about the creation of the universe. For the sky is no longer the limit. It is only the beginning.